Hi, and welcome to this week's chapter introduction. We're talking about implementing VLANs this week, and the slide deck I'm about to show you is fairly limited. The full slide deck is available in the chapter, so I'd like you to download that PDF and use it as a study guide if you like. It will have a little more detail on voice VLANs, and it will have a little bit more information on some tagging and some study guides. So the purpose of this one that I'm giving you right now is to introduce you to the topics, but I want you to explore some more on your own. So when we're talking about VLANs today, take a look at this object and you can see that we have 3 floors in the building, and on every floor we have people belonging to different VLANs. So people in the IT department are on each floor, and people on HR are on each floor, and people in sales are on each floor. But if you're on the 3rd floor, you're in sales, you cannot communicate with PCs and other VLANs on that floor, but you can communicate with PCs in your department throughout the building. That's because inside the building, the IT department configured virtual local area networks. Instead of having one big network where everybody talks to everybody, it's been restricted down to where certain groups can talk to each other, creating their own virtual local area networks. And inside a switch, these virtual local area networks have the same attributes, limitations, and benefits of a real local area network. And some of those benefits are limiting broadcasting domains, better security. Because the size of the broadcast domains are smaller, there can be more of them, and that can make things better as far as the limited traffic or traffic being limited to germane traffic for that computer, improved IT staff efficiency, and better management controls. Now there are different types. There's the data VLAN, default, native, and management. You don't have to worry too much about these terms. Well, they'll be defined throughout the chapter. But the management VLAN will be doing some work in, and the native VLAN will be setting that up. But the default VLAN is the VLAN that comes out of the box. If you just buy the switch, plug it in, plug some cables into it, and use all 24 ports or 12 ports or whatever there are in one local network, it's going to work just fine. It won't be managed at all, but that's the default, and everybody will be in VLAN 1. So if you take that switch and type in show VLAN brief on a switch that's just been booted up, it'll look like this. You'll notice that there's VLAN 1 here, and its name is default, unimaginative, because you haven't named it yet. We'll show you how to give names. It's active, and all of the ports over here are in VLAN 1. So that'll be changed when you manage it and you decide that it's time to make things change. So you might name it this way. You might type in VLAN 10, faculty staff, and give it a name. So here's VLAN 10 here and VLAN 10 here. Now notice they're on the other sides of switches. You have 3 switches here, and they are trunked together. These connected lines, the dotted lines here, indicate a VLAN trunk. And the VLAN trunk is configured to carry tagged traffic for VLANs 10, 20, and 30, and 99. VLAN 99 in this case will be the management VLAN up here. So all 3 of these VLANs in different parts of the building are allowed to travel between buildings on these trunks through tagging. So we've talked a bit about broadcast domains. You can read about that. I'm not sure how that slide slipped in. Here's the tags. And this is what a frame looks like when a PC on one floor has to talk to another. It goes to the switch for its own floor, and that switch has to send it up to another switch. Before it sends it, it wants to make sure that traffic stays in its own VLAN. So it tags that frame and says, hey, this only belongs in VLAN 10. Or whatever name it is. It gives it a number right here, it identifies the VLAN, and sends it on up. And then the next switch, who has that destination PC, will remove that tag and put it on in its proper VLAN. and that way the security stays the same. If VLANs want to talk to PCs and other VLANs, they need to go up to layer 3 and be routed between them, just as you would any other local area network. And there's a little more information about tagging here, that if it's native VLAN 1 out of the box, it doesn't need to be tagged because there's no security applied to VLAN 1. Now, voice, you can read the section on voice. Voice can have its own VLAN, and if the voice has its own VLAN, then that traffic won't be competing with any PC data. It will just be voice traffic, and it'll prioritize that data and forward frames on the one VLAN. And then the PC and the phone can be plugged into each other, and it will be tagged and trafficked at its own rate. And these are the switches we're working with. Now the numbers generally run 1 through 1005. I often create VLANs to suit the IP address, for example, and in the exercises you'll see, you might make a network that is 10.0 VLAN 10, a network that's 21.0 VLAN 21, just to help keep it clear in your head. But you can give a VLAN any number in these ranges, and it will work. Here's how you make a VLAN. Config T, and then VLAN, type the word VLAN, and give it a number. And then you can give it a name. Name, there it is. That's all there is to it. You give it a number, and you give it a name, and then on the port, it will show up. I'll show you in just a moment. Then you can assign an interface to that VLAN. So if you want Fast Ethernet 18 to belong to the student VLAN, which we've made VLAN 20, we numbered it VLAN, we called it student. Switch port mode access, you're making that port an access port, and then you give that access to VLAN 20. And that's it. And now 18 is in VLAN 20. All right. Although it doesn't show it here. Apparently this is the wrong slide. VLAN 20 student VLAN is here, but port 18 should be down in this group. Sorry about that. But that will show up. So I'm moving a little fast here. So show VLAN name student, here it is, and it's got VLAN 20 is named student, it's active, and ports 11 and 18 have been assigned to it. And if you do a show VLAN summary, you get that as well. So the show commands will help you understand what's going on. If you show interfaces VLAN 20, it'll tell you that it's up, and the hardware and the traffic rates and things like that. So again, now to make a trunk, you have to configure if an interface is going to another switch, it's going to handle trunking traffic differently than it would handle switch traffic. It has to tag the VLAN data going through it. You have to allow VLANs on it. So we do a config terminal, and then switch port mode instead of access, we're going to make it a trunk. And then we'll call it a native VLAN, and then allowed VLAN numbers, like down here, switch port trunk, allowed VLAN 10, 20, 30. After making it native VLAN 99, so that'll be the management VLAN as well. We move it to VLAN 99 for security reasons. That'll come up a little bit later. So we can do a show interface F801, all right, and it says no switch port trunk allowed VLAN. That's taking it back off of trunking and back into a regular mode. So the trunks have different modes as well: dynamic mode, auto desirable, and then no negotiate. And what happens is both trunks have to understand how it'll work. So if you have one dynamic, auto is in access, and then it can trunk in desirable and trunk mode. So you have to make sure that the types switch up. So these modes, the trunk modes, if you have trouble putting a trunk together, it could be that it's in the wrong mode. So it can't be in access mode if it's going to do any trunking. All right. That's important. And generally, if the other side's in dynamic, once you configure one side to be a trunk, the other side will pick it up. But not always. So that's a good troubleshooting clue. So when I mentioned giving VLAN numbers, IP network numbers, it's just to make it easy. So in this case, if you look over here at the web server 10.172.17.10.30, that's off on its own. It doesn't really need a VLAN, but over here the faculty VLAN is VLAN 10 is 172.17.10.24. It's in network 10, so faculty VLAN 10. All right. Now these trunks have to be allowed. You notice that PC1 can't connect. Well, that's because it's on a different, that the trunks have to be allowed. So this, it would have to be in the right, again, VLANs have to be in the same IP address as well. 172.172.10.21. Well, this is 172.17.10.21. So if the 17 and the 172 are different, the faculty PC1 is misconfigured into the wrong subnet. So one subnet per VLAN. That is a very important rule. So if you've gone through and checked your IP addresses, but it still can't connect, you have to make sure the VLAN's address, is it in the correct VLAN? If it's not, assign the port to the VLAN. Is the VLAN present in the database? If it's not, create it in the database. There can be all kinds of things that go wrong in troubleshooting VLANs. So pay attention to the troubleshooting section. Same with trunks. If you get a couple of things going wrong, well, you have to stop and think about it and think like a trunk and say, have I been given permission for this to go across? I've had all of those happen to me in troubleshooting switching issues. All right. And they're usually incorrect configurations, just like they say here. VLAN mismatches, trunk mode mismatches. I've committed all of these. All right. So with that in mind, you're off and running. Good luck with this week's chapter. We have a lot of good labs. I hope you enjoy them, and we'll see you in class.